All right, question number 17. We're going to evaluate cosine inverse of cosine 3 pi over 2. So we have cosine inverse of cosine of 3 pi over 2. Okay, so you got to remember the domain and the restrictions when we work these problems. So generally speaking, cosine inverse of cosine theta, for example, is just equal to theta, okay, when we're within our restrictions. We can only do an inverse on a function that is 1-to-1. So let me just pull it up from our course, the trig cheat sheet. I'm going to go to Sheets and Handouts and the trig cheat sheet. So I can just show you here. So when we do the inverse, I think it shows up here, we have restricted domains. So cosine only works when we're between -1 and 1. Okay, so that's from here to here, 0 to pi when we deal about radians. 3 pi over 2 is down here. Okay, so we have to kind of work and find the corresponding angle. So when we do cosine of 3 pi over 2, we end up here, which is outside of our domain restriction. So I have to look at the value. Whenever I evaluate cosine, cosine is the x, so you got xy ordered pair. That gives us 0. So what I'm going to do is I'm going to say, okay, cosine of 3 pi over 2 is equal to 0. So now I'm looking for cosine inverse of 0. So where is cosine equal to 0 in our range? Okay, that is this value up here. So that's the only other ordered pair. We would have 0, 1, and that would correspond to pi over 2. So you just got to find the corresponding angle, and so we end up with pi over 2. Okay, so without using a calculator, we want to evaluate this expression. So cosine 7 pi over 6. So again, we could refer to our trig cheat sheet if you have that unit circle memorized. It is the angle right below pi, 7 pi over 6, and that's the x coordinate. So that should give us a negative 3 pi over 2. So you will be here at this angle right here, and the x coordinate is negative 3 pi over 2, so that's what we're looking for here. Negative square root, sorry, why was I saying 3 pi over 2? Negative square root of 3 over 2. Negative square root of 3 over 2, not 3 pi over 2.